Hi, in this section of Data Science with R, we're going to be covering basic R orientation. The topics will include operators, variables, and commands. This doesn't seem like much, but there's actually a lot to cover, and so it should take up a full half an hour, probably split between two videos. For the operators, we're going to be covering arithmetic and logical operators. I don't need to list all of these. Some of them should look familiar on both sides. For arithmetic, other than the obvious, we're also going to be covering exponentiation, modulus, and integer division. And on the logical side, we're going to be covering many things, including not x, x or y, x and y. And that should also introduce us to the true-false types. And for variables, we have naming conventions, editing variables, and updating variables. The editing and updating might seem like they're kind of the same, but we'll actually show you how they're just a little bit different. For the command section, we're going to be looking at least 10 common R commands. We may look at more depending on how time goes. The command types that we'll be looking at will fall under categories of help, sequences and combining, data types, type conversion, environment variables, and then the ones that we may or may not get to will be under math/aggregation. Okay, so let's go ahead and open up RStudio so that we can get started with these. Alright, with RStudio open, you should recognize this screen if you looked at our last video. Don't forget that if you want, you can clear all of this text that starts off right here by hitting Control-L. Okay, so the first thing we're going to take a look at is operators. And one thing actually that I want to show you real quick before we do that, if you go to this little portion right here, it looks like two overlapping windows. If you click on that, you actually get this editor up here. So in this, we can basically write any R scripts, and we can highlight the text and run that. So I think just for our first case here, let's go ahead and do that. Let's set a value for x. So what we're going to do is we're going to set x to be 3. And by the way, for this notation right here, I'm probably going to use this interchangeably with the equal sign here and there. If you want to do this quickly, instead of having to type in each character, then you can hit Alt or Option and the minus sign, and that'll give you that symbol right there. So if we want this, in order to run it, so this, again, this is like writing a script if you're in Sublime Text or anything like that. It doesn't do anything directly in here. We could just save this as a script, so as an R file. If you highlight some code, then all you have to do is click Run, and it'll run that down here for us in the console. And so now we can also see that we have x as one of our global environment variables, and that it's set to 3. So this can be really handy in case you want to write several lines for a script, write a function, run it from there. Overall, quite a handy thing to have. So what we're going to do is just move this up for now. We don't really need that. Okay. So, on to the arithmetic operators. I'm going to just kind of breeze past the basic ones because I think pretty much everybody's going to get those. But let's say that we want to do 3 squared, or in this case x is set to 3. So let's do x squared. And we'd have x. We can either do 2 asterisks, just like we would do in Python, and that'll give us our 3 squared. Similarly, if we just typed the digit 3 squared. Now, in R, we also have the option of using the caret. So what we're going to do here is just do 3, and whoops, I guess we do 3 cubed. So we have 2 options in R, where in Python we have to use 2 asterisks. In R we can use 2 asterisks or this right here, so whichever you feel most comfortable with. And of course, addition, subtraction, division, all of those should be pretty obvious by now. So x, we still have that as 3, so we're just going to do x plus 1, and we can do a semicolon and put x if we wanted to, but there's no point in doing that at this moment. I just want to illustrate what that does. That'll print both for us, x plus 1 and x. Same thing with subtraction, division, so we don't really need to cover those, but let's go ahead and move on to the modulus and the integer division. So if you're not familiar with those, modulus is going to give us the remainder for division. So for example, if we wanted to do, say 20, and by the way, we need 2% symbols here, so 20 mod 10, and that's going to be 0, and that's because 20 divided by 10 has no remainder. Whereas if we were to do something like, say, 12 mod 4.5, then we would have a remainder of 3. And so that's really all the modulus is giving us. So when I say mod, I mean modulus. And one thing to note about that is that we could actually reproduce this functionality. If we were to reproduce this, we would have 12, and it would be minus, and this is one thing we're actually getting a little bit of an advance on here that we'll see later, is floor. So this is one of our commands, actually, I've planned on taking a look at. So we're just going to get a head start on it. So what floor does is it will essentially round down to the nearest integer. So if we do 12 minus floor divided by floor of 12 divided by 4.5, and we multiply that by 4.5, that'll also give us 3. So that reproduces that for us. We'll see another alternative here real quick to reproduce that functionality, and that'll be with integer division. So integer division is a lot. It's basically floor. That's pretty much all it's doing for us. So it'll tell us how many times a particular number can go into the first. So for example, let's use 12 and 4.5. If we do 12 integer division, so we have percent symbol, division, and then percent symbol. So it's division sandwiched between 2% signs. And 4.5, that's going to give us 2. So in this case, 12 divided by 4.5, the closest, or the lowest integer of that is 2. So for example, if we were to do floor of 12 divided by 4.5, we'll see that we actually get the same result of 2. So yeah, pretty straightforward. And so to look at that, if you see this right here, we used floor in order to get this result. So instead of floor, we can actually use that integer division if we wanted to. So 12 minus, and then we're going to have 12 integer division of 4.5, and we're going to multiply that again by 4.5. And that'll give us 3, which is the same thing we had for the modulus. So you can see that we have two ways to reproduce the modulus functionality, although I can't really see any sense in doing that since this is the shortcut. But doing this just helps you to understand what it's doing just a little bit better. And that covers everything that we need to for the arithmetic. So let's go ahead and move on to the logical operators. Okay, so the logical operators. By the way, just like in Python, we can use the hash or pound symbol to create comments. So moving on, let's go ahead and knock out these logical operators. The less than or equal to, greater than or equal to. I suspect that many of you may be pretty familiar with them, so we'll breeze through those just like we did for some of the arithmetic. They're just the same as in pretty much every single other programming language. So we can have 3 less than 4, and we'll get a true. By the way, in R, this is something good to point out, the true-false values are in all caps, whereas in Python, we just have the first letter that would be capitalized and the others are lowercase, so everything needs to be uppercase in R for our Boolean true and false values. So similarly, if we have 4 less than 3, we get false. And let's go with 4 less than or equal to 4. I think you kind of get the point here. So we can do that also with any variables. So let's go ahead and create another one for y, which is 6.5, let's say. And so then we can do x is equal to y. And remember, this is technically x is exactly equal to, and that's false. So if we were to set x to say, let's make it 6 point, so let's not do that, let's do 49999. So just to illustrate this exactly equal to component here, even though they're approximately equal, they're not exactly equal. And so then we can also have greater than, equal to, and of course there's not equal to, so we just need an exclamation mark and an equal sign, and so we have x not equal to y, and that'll return true because of course they are not equal. So now the last three, we have the not x, the x or y, and the x and y. Not to confuse you by having too many ands there, so it's just x or y. In addition to that, we have the x and y. Okay, so for the not x, that one is to be used, or not equal to x. I'm saying x here, but really it's just in general, x as being a Boolean variable. So whatever the not is, the operator has to be, or the variable has to be Boolean. So let's go ahead and reset x since I keep using that. We're going to say that x is false. Okay, so x is now false instead of a digit. So if we do not x, which is exclamation x, then we get true. And so I guess what you could say is the not, or the exclamation mark, what that does is it just inverts whatever the Boolean is. So it's the opposite of it. So if it's true, then not x. In fact, let's actually just illustrate that. Let's say that x is true. We're going to do not x, and we'll get a false. So pretty straightforward there. And now to illustrate the or with the and, what we're going to do is x is currently true, so let's go ahead and set y equal to false. So the or is for true-false statements. So we don't have to necessarily have specific variables that are already set to true and false, but as we'll see later on in the course, what we can do is use things like if statements, and those statements will be evaluated to either true or false. So this may be something that is really obvious to some of you, and to some of you it will not be, because this may be completely new to you. Okay, so let's go ahead and take a look at x and y, and we can see that one is true and the other is false. Okay, so for x or y, so the or is going to be just this vertical bar, so where you have the backslash key, if you just press shift and click that backslash key, then you get that vertical bar. And so in this case, what it's looking for is one of these must be true. So either x is true or y is true. And in this case, we do have one of those is true, so we get that whole expression evaluated to true. Let's reset x to be false. So now we have both x and y are false. And so if we reevaluate this, x or y, we're going to get false because neither is true. And moving on to the and, that would use the ampersand symbol. So if we evaluate x and y right now, we're going to get false, and that's because with the and, they both need to be true. So let's go ahead and reset one of these to true, just to illustrate this. So now we have the x and y are true and false, and if we do x and y, we get false once more. But if we set y to true, so now we have both x and y are true, then x and y will evaluate to true. So that's how our logical operators work. Okay, now at this point, I think what we're going to do, we're going to circle back to this just a little bit later to show you one more thing that is useful, so you're not seeing just these single variables with just a single return value. That'll be after we handle our variables and possibly our operators.